Here's example 11 of sum and difference formulas. So it's another establish the identity problem, just like example 10. And this time the identity is sine of a plus b divided by cosine a cosine b equals tangent of a plus tangent of b. Okay? So looks like there's a little more going on here. So just like before, the thing that you always want to do with every identity problem, establish the identity problem, the thing that you always do is just start on one side, pick a side, usually the more complicated side, but just pick one side, work on only that side, leave the other side completely alone. So since we're talking about sum and difference formulas, we're probably going to want to pick the side that actually has the sum angle on there. So sine of a plus b, we can use our formula sheet to express that in terms of sines and cosines without the a plus b in there. So if you want to copy this formula sheet that we've been using in all the previous examples so far, you can check the video description. There's a link in there. Click that link to get a copy of this. So anyway, sine of a plus b, we're going to use this here, sine of alpha plus beta. So even though this is in terms of alphas and betas, and that's a and b, it does not matter at all. Same exact thing applies. The point is it's sine of one angle plus another angle. So so if we use that, that's going to be sine of a cosine of b plus cosine of a times the sine of b. Okay, so that's what's going to happen there. So let's go ahead and start writing that down. So sine of a plus b divided by cosine a cosine b equals, so again from our formula sheet, sine of a plus b is going to be sine a cosine b plus cosine a sine b. So that's sine a cosine b plus cosine a sine b, all divided by cosine a cosine b. Okay, so now what we should do is split this up into two separate fractions. So we have one term plus another term, all divided by one single term down here with no plus, no minus signs. So, or no addition, no subtraction, we should say. So we can split that up into two, and that's going to be sine of a cosine of b divided by cosine of a cosine of b, and then plus, from this plus sign, cosine of a sine of b, all divided by cosine a cosine b. Okay, so all we did was just take this expression here, split it up into two fractions. That's all we've done so far, or all we've done in that step. So now let's simplify. Blah 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 cosine b on top, blah 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 cosine b on bottom, so the cosine b's cancel. And then here we have cos a, so those cancel. And now here's sine of a divided by the cosine of a, that is the tangent of a. And then we have plus sine of b divided by the cosine of b, that is the tangent of b. Okay. And that's exactly what we wanted. We wanted to show that this mess over here equals tangent of a plus tangent of b, and that's exactly what we just found out. Okay. So just like in example 10, you use the formula from the formula sheet, and then the rest of it pretty much falls out naturally. So this kind of had a tiny extra step compared to example 10 anyway. Example 10, there's pretty much nothing else to do after you use the formula. Just simplify, combine like terms and everything. But here we simplified, and then we had to remember that tangent is sine divided by cosine. So, but we see really, once we use the formula and simplify it, it's just not that complicated. So it's a good thing to keep in mind. Anyway, that's example 11 of using sum and difference formulas, and it's another establish the identity problem, and that's it there.